Hi everybody, thanks for watching today. We are finishing up section 4.1, Properties of Radicals. In the last video we started this section and I believe we made it to number 5. So that's where we'll pick up today. We need to talk about multiplying radicals today. So start out with a couple simple ones. It'll get a little crazier as we go along. But example 1 here, we've got the square root of 8 times the square root of 10. Nothing too hard. If you have a radical times another radical, you really just multiply what's inside of them together. So square root of 8 times square root of 10 will be square root of 80. Easy enough, right? But like we learned in the last video, now you can try to simplify this down. So I know 80 can break up a bit. So I think I have it all factored out all the way. And we know that the square root of 80 really equals 2 times 2 times 2 times 2 times 5. Now at this point, we were trying to find groups of 2 because this is a square root. I can find a couple of groups of 2. Each one of those groups of 2 represents 2 squared, which would cancel out with the square root that was around that part. So really, for each group of 2 that I circle, I can bring a 2 out front. That 5 has to stay in the square root because it didn't have a group. 2 times 2 is 4. So your final answer should be 4 times the square root of 5. Example 2 is kind of nice. It's just the square root of 6 times the square root of 6. When I multiply those, it'll be the square root of 36. And that one, we could do the factor tree, but I think you all have this memorized. The square root of 36 is just 6. Now, like I said, these last two get a little crazier because they're binomials. They're 2 terms each. So on example 3, we'll have the square root of 3 plus the square root of 5 times the square root of 3 minus the square root of 7. When we're multiplying a binomial or something with 2 terms times something else with 2 terms, we are going to use our old trusty friend, foiling. So we start with the first times the first. That'll be the square root of 9. And then we do the outside terms. 3 times 7, negative square root of 7. So that would be negative square root of 21. Then the inside terms, when we multiply those, it would give us positive square root of 15. And then the last terms, that would give us negative square root of 35. The square root of 9 right off the bat, we all know that that one is 3. So that part can simplify pretty easily. Now, none of these as they are look like they're like radicals. Remember, you can only add or subtract like radicals. The only chance we've got at being able to combine any of these is if they maybe were to simplify a little bit. The 21 can't because the only way it can break up is 7 and 3, and there are no pairs to circle there. 15, I think, is the same way. The only way it can break up is 5 and 3, so it can't simplify, and the square root of 35, 7 times 5 is the only way that one breaks up, so none of these will simplify any further, so we can't combine any more of them, and that's our final answer. Example 4, we've got square root of 3 plus 7 and square root of 3 minus 7. When you have something where all of the numbers are the same, but only the signs in the middle are changed, those are called conjugates of each other. So if you have some room to the side of your notes, you can make a little arrow. Those things are called conjugates. Conjugates are awesome when you multiply them together, and I'll show you why as we do it. But once again, we're going to do our foiling. Square root of 3 times square root of 3 is the square root of 9. Outside gives me negative square root of 21. Inside gives me positive square root of 21. And last gives me negative square root of 49. Square root of 9 turns into 3. These middle two terms, they are like radicals. So I have a negative square root of 21 and a positive square root of 21, which will just cancel each other right out. And then I have a minus square root of 49, which is just 7. 3 minus 7 is negative 4. So conjugates, like I said, pretty awesome when you multiply them together. All of the square roots will actually just cancel, and you'll get a nice whole integer like negative 4 there. So there's some examples of where we use some foiling to help us with these square roots. And then number 6 is all we have left on the notes. So let's talk about what it means to rationalize the denominator and practice some examples. Here is a little paragraph. You are welcome to write it on your notes or just kind of remember what it says. So mathematicians, and that means math books, prefer not to have irrational numbers like square roots in the bottom of the fractions, in the denominators. The process of getting the square roots out of denominators is called rationalizing the denominator. So as you can see on these first couple examples, they both have square roots in the denominator. According to kind of the math laws, that's not okay to have square roots in the bottom of the fraction. We have to get them out of there before it becomes kind of an acceptable final answer. And that process of getting the roots out of the denominators, that's called rationalizing the denominator. On example 1, I'll show you how to rationalize the denominator. What we're going to do is we're going to multiply the top and bottom of this fraction by the same thing. That thing is going to be the square root of 6. Now I hope you remember back, it's totally legal to multiply the top and bottom of a fraction by the same thing. Doesn't change our answers at all. But what will happen is on top we will have just 4 times the square root of 6. That can't really simplify much. On the bottom though, we'll have the square root of 36. Which is perfect because the square root of 36 is just 6. Hey, that's great. No more square root in the denominator. We have done our job. We have rationalized the denominator. Now this one actually can go one tiny little extra step of simplifying. The 4 and the 6 can simplify to be 2/3. And you've still got that square root of 6 up top. So that's your final answer right there. Now example 2, notice, not okay because we have a square root in the denominator. So we've got to rationalize the denominator. This one looks a little trickier, and it definitely is because it's 2 terms in the denominator there. We're still going to multiply this by the same thing on top and bottom. And some of you may be looking back at some of our previous examples and kind of know what's going on here, but we want to multiply this by the conjugate of the denominator. Remember, conjugates, you keep the same exact numbers, you just switch the sign in the middle. So 5 plus the square root of 3 is what we'll be multiplying by. And if everything works out right, all of the square roots in the denominator should cancel out. On top, I'm going to distribute that 2, so it'll be 10 plus 2 square roots of 3. On bottom, I'm going to start my foiling, so let's see. First, outside, inside, and last will be minus square root of 9. Like we saw before with conjugates, these middle terms should cancel out if you've done everything right. The square root of 9 we just know is 3. So on the bottom, all we have left is 25 minus that 3, 22. Hey, we did our job. No more square roots in the denominator. Way to go. Now, let's see. On top, we could simplify this because all 3 of those terms, we could divide a 2 out and cancel that 2 out. So what's really going on is if we factor out a 2 from the top, that would be 5 plus the square root of 3. And we can factor a 2 out of the bottom, excuse me, it would be 2 times 11. We can cancel those 2's out. So really, if there's a 2 in each of the terms, that's what's going on. So our final answer would be 5 plus the square root of 3 all over 11. Definitely a little crazier, but we did do our job. We got all of the square roots out of the denominator. Let's practice kind of a similar example. Example 3 here. So think conjugates. What's the conjugate of 6 plus the square root of 5? Well, it's 6 minus the square root of 5. So that's what we're going to multiply top and bottom by. On top, distributing the square root of 5, square root of 5 times 6. Can't do much with that. It's just 6 times the square root of 5 minus the square root of 25. And then on the bottom, we will do our foiling. Inside and last. Hopefully everything on the bottom will simplify the way we want it to. Those middle terms do look like they cancel, which is what we want. That last term, the square root of 25, we know is just 5. So 36 minus 5 is 31. On the top, we have 6 square roots of 5 minus 5. There's nothing that can divide out of all 3 terms there, and so that is as far as we go. We can't simplify it any farther. But we did our job. We got all of the square roots out of the bottom. So when you're rationalizing the denominator, you have to remember a couple different methods. If the bottom is just one term, multiply it by itself. If the bottom's 2 terms, then you use conjugates and multiply by the conjugate. That is it for the 4.1 notes. Thanks a lot. As always, you're awesome. Hope you're back in real class soon. Have a lovely day.